Hello and welcome. Welcome to the sixth episode of the Data Science Daily series, and especially on this Saturday night. Today, we will cover very interesting subfields of data science which are making a lot of impact. Things like recommendation systems, like mathematical optimization, and also product analytics, which is very widespread in product based companies, especially which are having the business on their websites, right? All right, without further ado, let's get started. So let's first start with recommendation systems, right? Now, what are recommendation systems? Recommendation engines are systems that suggest services, products, or information to users based on data analysis, right? So if you have ever visited Amazon and you tried to buying a product, you will see that Amazon, based on your search history and based on other factors, it recommends other products to you as well. And most of those other products you might feel are relevant to you, right? So Amazon is using recommendation systems at a large scale. Similarly, Netflix is using recommendation systems to recommend movies to you based on what movies you have watched, what movies you have liked, and so on. Now, how do recommendations engines actually work? There are two main methods in which recommendation engines can be built, right? And we are talking about this on a very high level. There are more specialized methods, which I'm not going into today. The first method is called content-based filtering. So let's say you want to recommend a product to a user, right? And you have an inventory or you have a category of 1,000 products. How would you choose which product to show to the user? So what you can do is you can look at previous items that the user has liked or used, right? And based on the attributes of the previous items, you can match the attributes of the items in your entire available set, right? And see which items are the most similar to the items that the user has already liked. So based on the content and the item attributes, you're filtering down the main relevant product that you want to recommend to the user. So this is called content-based filtering, right? And this is very logical as you think about it. Now, another way to think about recommendations are, right, like you have a group of friends and you know that two people in your friend group are sporty. They like sports a lot. So you have seen one person buy a specific type of gear, right? Let's say for cricket, and another person, right? Your second friend is asking you, right, one to one, what kind of a gear should I buy for myself? So what you do is you see that, okay, these people, these two friends are very similar to each other in terms of their likes and dislikes. And one person has already bought their sports gear. So why not recommend the same item to this friend as well? So this is called collaborative filtering, right? Based on items that a similar user likes, new items can be recommended to the user, right? So here you're not looking at item-based attributes. You're not looking at the previous purchase history or the like and dislike history of a particular user. What you're looking at is, did a similar user like a particular item? If so, right, I should also recommend that item to this new user. So it's kind of a collaborative approach where the similarity is focused on what similar items that users like, right? And there are other kind of collaborative filtering methods like item to item collaborative filtering, which kind of outperformed this collaborative filtering for Amazon a decade back, right? And even more advanced methods like deep learning and artificial intelligence actually outperformed even these two methods that I have just listed, right? So there is a lot of research which is going on, but these are the two most widely used methods. And there is matrix factorization, which is a central technique in recommendation systems, which we will not go into now, but just a terminology to keep in mind. How are these solved, right? So these are the methods, but how do these get solved behind the hood? That is using a method called matrix factorization. Think about music recommendations, right? KKBox uses 30 million tracks in their algorithm, right? Spotify also uses a large amount of tracks. Netflix recommends movies, Amazon recommends products, and everywhere, no matter where you go into today's world, right? You have recommendations in the different products that you actually get. Think about Netflix, like movie recommendations. 80% of Netflix viewer activity is driven by recommendations. All right. So this is about recommendation systems, right? And this is a very interesting subset of data science, and it is very, very relevant to organizations as well to improve the customer experience mainly. Now we will look at another subfield, which is called mathematical optimization. And this technique and this field actually is part of operations research, and it is having a very high value addition to no matter what kind of a use case, right? An optimization use case you are looking at, the value that it is going to add is going to be high. The reason being, it's optimizing, right, for your resources. So you're saving cost, you're saving time, and so on. Let's understand what is mathematical optimization first, and then we will go into understanding what are the variety of applications in the industry and across different sectors that mathematical optimization solves for. So what is mathematical optimization? Right? You must have already done linear programming in high school, right? Where you were given a set of constraints, you were given a set of variables, and you were given an objective function that you wanted to optimize for. So mathematical optimization refers to finding the optimal solution, right? This is the first step. Finding the optimal solution for an objective, right? Objective can be, let's say you want to maximize your profit, right? Subject to a certain amount of constraints, right? That these are the maximum number of people that you can hire, right? For example, and this is your fixed cost, and there are other regulatory constraints as well. So there can be a lot of constraints in business, and the objective generally is to maximize the profit. In some cases, to also maximize the revenue, right? And how do you find an optimal solution, right? What levers do you change? Which resources do you focus more on, and which resources do you focus less on? Like, how do you do that trade-off analysis so that your final objective is attained? That is the field of mathematical optimization, right? And it has a lot of applications. In operations research specifically, this involves creating a digital twin of the actual operating environment, right? You are basically mapping out all the activities of the actual working environment and creating a digital twin out of it using a detailed mathematical model. And this detailed mathematical model is basically allowing you to optimize for the different things in your actual operating environment. So we have understood what is mathematical optimization at a very, very high bird's eye level. And it is composed of three main aspects. What you're trying to do. So firstly, why are you trying to do optimization? The reason being, you have a limited set of resources. If you had infinite resources, you would not need to optimize for it, right? So you need to optimize because you have a limited set of resources. What are you trying to optimize? That is your objective function. Do you want to minimize or maximize that objective, right? That is included in the objective function itself. Subject to certain constraints because your resources are limited. So you have a few constraints that you generally have in real world scenarios. And you're trying to find an optimal solution, right? What is the best solution that you can get at? Now, one interesting use case, which I particularly find interesting, is route optimization. Suppose a person is out for delivery, right? And it's out to deliver your package. Now, which route should that person take in order to reach you in the minimum amount of time and to reach other customers also along the way in a particular route that they are saving kilometers and they're saving fuel as well, right? So they're saving fuel, they're saving time. What is the route that they should take so that they deliver all the packages in the minimum amount of time with the minimum hassle and with the minimum effort as well? That is route optimization. And for UPS, which is United Parcel Service in the US, route optimization is a major optimization use case just because of the volume of parcels that UPS delivers, right? Just because of the volume of deliveries that it does, similar to what Amazon also does. So both of these organizations have very strong route optimization teams, right, which actually perform this. And Amazon also recently, I think a few years back, had launched an open source competition, a research competition for improving the state of the art in route optimization, right? So that was very interesting, and I had also started that out and looked into the problem statement, and it was very, very interesting how people around the world who are collaborating and actually trying to solve that problem statement, like advancing the frontier of route optimization research at Amazon. Another use case in HR could be workforce scheduling, where you're expected to, let's say, be in office, right? The office is expected to be operational 24 hours. Now, a person cannot be in the office for 24 hours. So, how do you schedule your workforce such that you have the minimum set of workforce at any given point in time, right? How do you set the schedules? And this can become complex if you have a lot of departments, right? And you have a lot of different requirements across projects, across time zones, and so on. So how do you do the workforce scheduling in the most optimum manner so as to also keep employee satisfaction and also fulfill the requirements of the project that you're actually trying to deliver? Let's look at a few other use cases now, right? Across different functions. So we'll look at supply chain first. There is truckload capacity optimization. You have a truck, right? This is typically what people do when they are moving their luggage from cities, right? And they hire a lift and shift team. So the lift and shift team, what they do is they have a truck, they load the parcels, but have you seen how they optimize for it? So parcels are of different length, width, and height, right? And you want to be able to optimize such that you're able to fit the maximum amount of packages in a truck without overloading the truck, right? Without exceeding the maximum capacity of the truck. And always prioritizing the high value items first, like keeping brittle items aside, keeping similar items together, and so on. And this would, imagine this to become at a large scale, right, for big organizations where they need to transport a lot of things, right, to different places. So there can be a combination of truckload capacity optimization and route optimization as well, right? It might be possible that you need to optimize the truckload so that it takes the minimum route, and it's able to carry the maximum amount of load. So that's one use case in supply chain. Inventory optimization, right? How do you optimize for your inventory so that you're not sold out and also you don't have excess inventory? So you're not suffering from excess inventory, right? Because you need to store that inventory and you need to have an additional cost for storing excess inventory. So you don't want that, right? And on the other hand, you don't want to have so much less inventory that you are running out of stock. So how do you optimize for your inventory? And this typically needs a demand forecast in the backend, where you have an idea of what the demand is going to look like in the future. Production optimization, again, how much should you produce, right? This is going one step backward, right, in the production itself, right, before even the inventory. And then shipment routing, which is what we just talked about. In finance, there is portfolio optimization. What is the best set of or best portfolio of assets that you should hold in order to optimize for your returns, right? And also keeping in mind that you have a constraint of the risk that you can take. You cannot take a lot of risk, right? You cannot take infinite risk. Sales and marketing, revenue optimization, and profit optimization, right? Very typical. How much marketing budget should you spend, right? And in what best tactical way should you spend it so that your revenue and your profit is maximized? Obviously, it needs to be maximized, right? So we are assuming optimization is maximization automatically here. Government, there are a lot of use cases like vaccine distribution. In COVID, how did the government actually distribute the vaccines, right? Where was the need higher, and what was the delivery time to that particular location, and so on. So all of these things need to be kept in mind, and there are many more applications. This is the fascinating field of mathematical optimization, right? Which actually, if you look at the Gartner hype cycle, it reached the peak of inflated expectations way long back, right? And at this point, it is at a continuous stable curve, right? So it is delivering value, but it is not so much hyped, but it is still having a lot of value. And it is very important if you're interested in mathematics and if you want to go deep into this specifically, right? This is not taught in a lot of data science courses and boot camps out there. So make sure you're exploring this field because it has a lot of jobs, right? It has a lot of value, and it is very, very logical as well, right? So definitely explore this field. We will also cover this in our future videos. Now let's go on to one more domain, which is A/B testing. And this is a particular domain which is the field of statistics, right? And we generally consider it as data science nowadays, right? So you will see postings for data scientists where companies are actually looking for people who can perform A/B testing, right? We have a traditional view that data scientists are people who are generally performing machine learning, but there is so much more than machine learning within data science. And this is one thing you should always keep in mind, right? Don't be limited to machine learning. Look out for learning optimization, algorithms, A/B testing, right? Recommendation systems, how they work, right? And so on. So let's understand what is A/B testing. A/B testing is a randomized experimentation process. It's a randomized and it's an experimentation process. And what are you trying to experiment for? You're trying to experiment for whether which of the two or more versions of any variable, right? Like a web page design, a particular page element location on your web page, which of all of these versions, right? If you show them to different similar group of users at the same time, right? So you're showing different versions to different customer groups, but at the same time, right? Why at the same time? Because you don't want to have the time variation in it. So at the same time, you show different things to different set of users. You want to determine which version leaves the maximum impact and drives the business metrics. This will become more clear when we take an example. So let's start with an example. Let me also have my pointer on. So you have version A, where the page is looking like this. You have the page title, you have the news blog, you have the sign up form here, and then the other parts of the page. And in the version B, you have the sign up form in the bottommost right. Right. So the question is, which of these versions is better than each other? And the color is also different of this particular item, right? Which of this is better? Now, what you do is whenever visitors are coming in, you randomly distribute them, right? So that the distribution of incoming visitors remains the same across these two groups, right? So how do you randomly distribute them such that the distribution remains the same? One way to do it is you could segment the visitors based on different parameters like demographics, age, gender, education, income, and a lot of other things, right? But that has to be a logic-based, manual kind of a clustering or a segmentation that you need to do. Another way to do it is based on the time frame that the customer is visiting, right? Like every second, if there are incoming traffic, right? The even timestamps you can put into version A, the odd timestamps you can put into version B. That is, you can allow version B to be the version to be shown to the second group, right? Now, if you do the randomization kind of like this, then the distribution would be mostly similar because there is no reason to believe that people who are coming at even timestamps are different from people coming at odd timestamps, right? There will be a equal distribution given a large sample size. So always make sure that your visitors are randomly distributed. That has to be important, very important for actually saying which version is better. And then you monitor the outcome of the activity, right? What are the business metrics? So here you see that there are 75 signups and there are 50 signups for version A and 75 for version B. And you can make a statement, right? Version B is better than version A, but this needs to be statistically backed. And this is where statistics comes in. Is this difference of 25 signups actually significant? And just by having a ballpark, right? Just by looking at this, it seems significant. So we are skipping the statistical part for now. But in any A/B testing, you always have a statistical test which is involved, right? A hypothesis test. And this will become very clear, right? What a hypothesis test when you are going over to the statistics module. Finally, what is the impact of A/B testing? Small changes with a huge impact. Microsoft Bing's experiments showed that slightly darker blues and greens in titles and a slightly lighter black in captions improved the user's experience. When rolled out to all users, the color changes boosted revenue by more than $10 million annually. Right? And this is the surprising power of online experiments. Control is just the A version, treatment is the B version, right? So that's just a terminology that we use. Control, and which is the default, and treatment is what we are trying to test for, right? Similarly, in hypothesis test, we have the null and the alternate, right? Kind of like that. All right. So today we discussed a few subfields of data science, and I hope you had a great time understanding these different subfields. So if you have any questions, as always, feel free to put them in the chat. Else, I will see you tomorrow for understanding the data science development process overall. Stay tuned. Have a lovely Saturday night.